In this video, we want to look at alternating current generator. Now, we know that electric generators take in energy by work and transfer it out by electrical transmission. Let's just make a little sketch of what we are talking about. Let's say this is a magnet and we have a loop. This is another magnet. This is the slippery ring. The slip rings, there are two. The slip rings are two. Slip rings. Two of them. Now they rotate. We have something, a kind of external rotator here that rotates it in this direction. Now there's what we call brush that connects it to an external circuit. Now this is the loop. So when this loop rotates in a magnetic field, current is produced. For example, in a hydroelectric plant, falling water directed against the blades of a turbine produces the rotatory motion. In a coal fire plant, the energy released by burning coal is used to convert water to steam actually, and this steam is directed against the turbine blades. Now, if we plot the graph of the EMF against time, we will have something like this, and this is the electromotive force max. So we have a relationship that says that E max, electromotive force max, is given as N A B omega, where this is the number of turns that is produced in this place, the number of turns that we have. Another word for it is windings. This is the area, this is the magnetic field, and this is the angular speed that we have. So this question says a simple generator has 200 loop square coil, 8 cm on a side. How fast must it turn in a 0.4 Tesla field to produce a 12 volt peak output? So remember the equation that we have, the relationship that E max is equal to NAB omega. And here they want us to calculate how fast. The only way, which is the frequency, we know that the only relationship frequency has, or one of the relationships that frequency has is with omega, where we say that omega is equal to 2 pi f, if you can remember this. So, and in this case, we were not given omega, so we need to calculate for omega first. So if we have that E max is equal to NAB omega, for us to make omega subject of the formula, it means that omega will be equal to E max over NAB. So now the turns given to us 200. So our N is 200 loop, 200 turns. Now they said that it has area of 8 centimeter on one side. Since it is on one side, remember it has two sides, so we need to square this. So area, we need to square the figure given to us. 8 squared is 64, and 64, if we convert to meter, we're going to have 64. If we convert it to meter, we have times 10 raised to power minus 4. Because it's supposed to be times 10 raised to power minus 2 if we convert to meters. But since we're squaring, it becomes times 10 raised to power minus 4 meter squared. That's what we have here now. So we still have that our B is 0.40 Tesla. Now we have that the E max given to us, the peak, is 12 volts. So if we fix all of this into this, we will have 12 over 200, N is 200, times 64 times 10 raised to power minus 4 times 0.40. And if we calculate that, if we calculate all of that, E max N A B. So if we calculate that, we're going to get approximately 23.44 rads per second. And since this is our omega, we can now say that F from this equation, F is now equal to omega over 2 pi. And if we fix that, our omega is 23.44 over 2 times pi is 3.142 something. So if we divide that, we have approximately 3.7 hertz. That is the frequency. Please, if you haven't subscribed to our channel, do well to click the subscribe button. Leave your comment in the comment section. Thank you.